Hi, and welcome back to the fourth and final week of QGIS tutorials. This week, for the QGIS tutorials, we will look at how to make animated maps in general, work with spatio-temporal data within QGIS, and then there will be a short tutorial about exporting your project as a web map. So up until now, we've been working with static maps mostly. So now you will learn how to work with and how to make animated maps and web maps. Starting off with the spatio-temporal tutorial. So by the end of this tutorial, you will learn how you'll work with temporal data and how to export animated maps from QGIS. We will also take a look at plotting within QGIS. So how to create plots that you can use to explore and use to add some added value to your maps. And for that, we will use this data plotly library, or plugin rather, that's built on this Python plotly library. We will be working with two datasets in this tutorial. First one will be this NASA remote sensing dataset. That remote sensing data has been used to derive probable wildfires, or at least sort of heat events from the satellite images. And that has been preprocessed so that's limited to just Finland. So we'll be working within Finland. Then there will be this auxiliary dataset, Korean industrial areas, that we will use later on to filter the data a bit. So always you can download this and all the style files and the processing models following this link, or from the QGIS files .zip that you will find within this data. And there you actually find it here, QGIS files. So let's start off. Let's first import the data. So this time it's a CSV file. So you can import them from Data Source Manager and from delimited text. Just navigate to where you have the datasets downloaded and import file data format. And here you should have this point coordinate selected, and x-axis should be longitude and y-axis latitude. And you can see that what kind of data we have. So it's a really simple one, just one coordinate in one column, and then the date that observation was made. And this should all be correct. So it's decimal values and then a date field. Let's add that. And with that, we should have our datasets here. And if your map looks a bit different than mine, like these points, so just remember to set your CRS to something sensible, such as 3067, which is valid for Finland. We'll do two small adjustments to this dataset. So first we'll project the layer from this global CRS to our local one. That's a pre-projected layer, and then we'll need something to uniquely identify each of these points. And since our data by default does not have that, so we could use this nice small tool called add auto incremental field. So on the reprojected, we just say that, okay, start from 0 and then count upwards from that. We'll work on this incremented layer that indeed has a new auto column that has this running number. Good. So we've now done all the preparations. Now we can look a bit on how to work with temporal data within QGIS. So first add maybe a background map like this. And then from properties, there's this temporal tab in here. So here you can set it so that this field or this layer temporal will set that work with a single field with date and time, because that's what we have. So here with this date when this event of wildfire was observed. And then because this will be drawn dynamically on the map, we also need to set some sort of duration for this event. So how long does this last? And we don't have that information by default, but we can just say that, okay, we want it to last 1 month, which is unrealistic, but it's good for visualization purposes. And if we were to want to sort of start from 0 and then over time add more events to the map, so you could check these acclimate features over time. But we won't be doing that. Okay, so now you have this clock symbol here, so that means that temporal features are activated for this layer. Next, we'll need to still open a panel called temporal controller. So this is where the magic actually happens. There are multiple options here. Just fixed time range. You could like explore a certain point in time with this. Okay, now it's the whole year, start from 2022. But we'll be working with this animated temporal navigation. So here, is the current frame and how long that frame lasts. So now it's actually just 1 hour, which isn't great. But let's first set what's the animation range. So if you click these arrows here, then you set the range from whatever the range of the full data set is, which is about 10 years. Then we'll modify this animation step. So how long, if you now start this animation so that it goes 1 by 1 hour advances, each step advances by 1 hour. So it's way too small for our purposes. So we can instead set so that advance by 1 week. And I can see as this sort of as the map advances, so then the events that happened during that time period appear on the map, and they stay there for 1 month, as we set our event range to be that. If this is too slow for you, there's this hidden option here where you can set the frame rate, so how many frames per second is happening. So if you set it, for example, to 5, so then the map advances a lot more faster. So okay, this looks pretty nice. There's a few odd things here. For example, if you zoom here and you have a background map enabled, you might wonder why there's almost always some sort of event observed in this specific place. And if you have the background map, you actually see that there's this steel mill or steel factory at this specific location. So then what that tells us, that actually it just showcases that the data isn't actually showing only wildfires per se, but any sort of heat signal which this steel mill exerts as well. So we need to maybe do something about that. So we'll actually have a more realistic set of features that show actually the wildfires that we're interested in. So we now actually have some almost 12,000 data points. So let's filter them down a bit. And for that, we'll use the auxiliary layer I mentioned earlier. So from the data, there's this Korean industrial areas, as you can pull here. So I extracted it from Korean land cover vector dataset and filtered it to this industrial or commercial units field type or land use type. So with this land use type, we can find the places where there's likely something happening that's not a wildfire, but is actually an industrial operation. And it's not perfect, it's just a heuristic, but it works okay-ish. Good. So what we'll do here is first select within distance So we'll also have a small buffer around these features because some of these points may fall just outside of them. Let's select features from incremented using Greenland areas. The features are within 1 kilometer, so 1,000 meters. And then create a new selection. And that. And you can see that, for example, all of these points here in Brahe are selected. And now we can actually invert this selection so what we actually want to keep are the points outside of these industrial areas. So what you can do that from incremented, and there's this invert selection option in here. So just press that. So now we have some 2,400 points selected. And then you can, for example, run extract selected features on incremented. So we'll create another new layer. Now only contains these points that we want to keep. Excellent. So now we have reduced our amount of data from 11,000 observations or almost 12,000 observations to less than 1/4 of that. But this should be a better market reflection of our topic of interest. Okay, moving on to some interactive plotting. So now we want to describe this data. So of course we have the map at our disposal. That's a powerful tool, and which we will use, of course, to show the sort of spatial distribution of this data. But what if you want to know, someone who you want to show the data to wants to know something other about it, like they want to know when do these wildfires occur, for example. And for that purpose, we'll have an animated map later on. But actually, we can also use this data plotly plugin to create these plots that can use to show these features that are not best mapped, perhaps. So as always, make sure to install it from plugins, and that should add a new selection on your toolbar, which for me is hidden here. But you can just activate it and they will show this dock. So basically now, this is where we will work with this data plotly tool. So we want to examine this filtered dataset in more detail. Shut down this temporal controller for a while to get more screen space. So here you have different options for what kind of plot you animate, like what kind of chart. By default, it's a scatter plot. So you could, if you have two variables that you want to show their sort of relationships, so you could use that. And just please explore around here a bit. But we will use a simple bar plot. And then for that, we need to provide what's the X field, what's the sort of category, and what's the Y field, so the value that we're plotting. For the category, we say that use month to group the dataset based on which month of the year this observation falls into. And then for the values for the Y field is where that auto-incremental field comes into play. So we'll count the number of unique observations per month. Then from the additional plot customizations, I'll change the bar mode to overlay. Then you could fine tune all of this stuff, like the font size and font type and plot title and labels and so forth. But let's first create the plot. So just press create plot. And you can see this distribution. It shows the sort of temporal distribution of these wildfires, and it's quite skewed towards May in this case. I'm not sure if that's accurate, but I did find this one source where that was sort of corroborated, at least for year 2024. I guess there's a lot of variation, and I guess this type of satellite data doesn't capture everything. Nonetheless, it looks at least sensible. So if you want to use this sort of to make a check on your data to make sure that it's not complete nonsense. So then a distribution that is peaking in the sort of summer and warm months stay on in Finland. So that makes sense. Okay, so now that we checked the sort of temporal distribution of the data, so next let's create a X-bin map. So we'll count the number of observations to a grid that covers the whole data set. So you can create this grid, use the create grid tool to make a hexagon map, take the extent from the selected features layer. And then for the spacing, we can set it as 25 kilometers, so quite coarse. That should be sort of fine for this data. Yep, and then next we'll count points in polygons. Points selected features, the rest can be left as it is. Then there's a new layer called count. And then still, because a lot of these grids don't have any observations, so just to make our map more visually pleasing, so we'll filter out those empty grids by saying that num point should be over value of 0. And that, then you have finally this extracted attribute layer. And this you can style with a graduated style. Uses num point. And do something like oranges, for example. Level to red. Yeah. Yeah. So you could maybe make a map like this, throw it to a print layout, maybe adjust some properties like make the portrait to fit the shape of Finland better. Then add this layer here. Just extends a bit, for example, and then you'll have something like this, and then add the legend, add the data description and all of that, and the scale bar, all of these map features that you might need. Now, another interesting thing that we can do here is actually to combine that plotting exploration that we did earlier with the map. So actually, once you have installed it, you find this new option here in the layout window called add plot item. So we can click that. It's a bit awkward here. And unfortunately, I think it's not very easy to get what we did earlier in the other view, sort of to get it automatically here. So we might have to just copy paste our stuff from there, make sure that the layer is actually correct. Oh, and actually that we have the bar plot, and not something completely different in there. Yeah, something like that. And we could have this title and label customization just to make anything a bit more visible at the scale that it's supposed to be. And always as we make changes to these plots, they are not automatically updated. So I will place this update plot option in here. And now here at layout options, you would do all of this visual adjustments. So change the titles or labels of these. I can go to that. So overlay. Yeah. So you could keep adjusting this to make it so that everything is nicely visible and looks good. Maybe we'll extend this width of the paper to, we need to actually extend it quite a lot. And then for example, put the plots here, or maybe make it a bit less drastic and have them just here, however you wish. So you can make this, and then please explore, make another type of plot. I have an example here, one I thought was quite interesting that sort of adds something to even the spatial aspects of the map that we couldn't explore before. So if we add another plot, and we can add as many as we want here, also keeping in mind that not to make our map sort of unreadable and overload the reader with information. We can still set like the features, and then actually we'll, instead of counting by month, we'll actually count the observations by the latitude. So we'll use this use the latitude filter advantage. So we'll say that, okay, take from the field, or we could take it from the geometry itself as well if we want, and then round it up to the nearest full number, and then count the number of observations by that full number. And we can actually change it to horizontal to make sense for this latitude thinking. That, and then update the plot. And now what you have here, not quite yet actually. Change it to overlay. Okay. So what you have here is in the y-axis the latitude number, which for Finland varies from around 60 to somewhere a bit under 70. And then the count of observations per latitude. So for example, you can see that there's this a big peak in the lower latitudes. In general, it's a bit more sort of distributed towards these lower latitudes. And these are linked, for example, to these clusters of observations here. So that's another way to give a quick overview, even of the spatial features of the data to the reader. And for your actual map, you would of course want to add a proper title that explains what's happening in these plots. But this is just to demonstrate the principle. Okay, moving on to the animated map section. So everything that we just showed is quite cool, but the outcome map that we will get from that is still a static one. But if we keep working on this temporal controller here, so have the temporal panel visible. Yes, so make sure that the layer that you're working on is temporal. Adjust it if you need, using the instructions before. So we just run it. So you see that these events are popping up and away, which is already something. It's quite nice. We can do a lot better, so we can visualize these observations as well. So we start working with the visual style here. So we want to again use data-driven, data-defined overrides to our advantage. And we'll first adjust the size. So the size of the features after the point. So now this time you select assistant. And here you can sort of select what is the source of your observations. And we'll have this quite complicated looking expression as the source. So basically this expression is returning the date difference between the current date on the temporal controller, so current frame, for example, here, and the event date. And these values will range from 1 to 30. So because our observation will stay there from 1 day to will stay there for a month, so 1 day to 30 days. And then we can, for example, set that the output should range from 1 to 6. Now if you run this, so actually I can see that these events pop up nicely and then they sort of enlarge and then disappear, which is again better. But we can adjust this dynamically quite nicely. So if you enable this apply transform curve, so instead of having this linear rise from 1 to 6, so you can think of this curve as the x-axis as symbolizing time, and y-axis is symbolizing size. So what x-axis will be a date from the beginning towards the end, and then size from 6 will be at the top and 1 will be there at the bottom. So if you want to, for example, change it a bit so gets to the maximum size quickly and then it sort of fizzles out. You can see how it looks like. Yeah. Then now they appear and then disappear. You can work and make it so that you're happy with it. But then we can still add another nice visual flair here, so we can do the same thing that we did just now for opacity, so the transparency of the feature. So take the same expression as the source. Let's range from 1 to 30. Then apply a transform curve. So here you can sort of play around a bit. Like I said, it's maybe so that first it starts from low and then it has this peak where it's sort of visible and then it starts to disappear. And again, adjust the disappearance a bit later, so something like that. Yeah. So keep working on this for as long as you're happy, but yeah, just keep the principle in mind that x-axis is time and y-axis is the value, which in this case ranges from 0 opacity to 100. So in other words, 0 will be completely transparent and then 100 will be visible. Yeah, and you have something like this in here. Change the color a bit. I guess the red stands for symbolize fire. Yeah. So once you're happy with it, then you can move on to exporting this animation. Unfortunately, this temporal exporting works a bit different than the traditional way of exporting maps from QGIS, which would be through the layouting tools. So we'll have to actually just export this map view here. So what's visible on the map at any moment. So that will be our export. So think of this map window as your layout page. And if you need to, for example, now we want to make this a bit smaller so that this kind of we want to make map be a bit slimmer so that it suits the shape of Finland better. We could do that by adjusting these other panels here. So if we just export this map window, so then it's not actually a great help to the reader because they don't know what's happening, what's shown, when is this event being shown. So we need to add some sort of labeling to make sense of this map. So unfortunately, like I said, we don't have the layout tools and text tools in there, but we have an alternative through what I call decorations. So from view and decorations, there are multiple options. So if you want to add, for example, a scale bar or north arrow, you can do it from here. What we'll use is this title label to our advantage. Label it and, for example, say that it's wildfires in Finland for our time range. But then it adds this ugly bar here at the top. But thankfully we can adjust it quite a lot. So again, from decorations and title label, so we cannot add, to my knowledge, at least multiple ones, but we can work on this one. We can immediately see that it's too small, so we should increase the font size. Then we can remove this background color here, maybe add to top right. And this margin from edge is what you can use to sort of play around and move the text. So we cannot sort of do it manually from here. We can use this values. Like I said, it should be 25 and 25 millimeters from the edge, and a bit less. That's, I guess, dependent on your duplicate map. What about the timestamp? So actually we can insert it right here at the title label. So instead of having just the text here, we should have an expression that forms our text. And we can use this here. So there's multiple things happening again. So concat says that formulate a string based on inputs here. And this format date takes the current time of the map times start time here. The variable is the current time of the temporal controller. And then this format date function changes that date to what we say here, which is a month and a year. So we want to just have it at the monthly level to make it easier to read. So that's a lot better. So then all that's left to do would be styling. So what went on for my ideas, for example, so I thought that this OpenStreetMap background map is too noisy. You can't make sense of these labels in any case, and we don't need that amount of information. So maybe for someone who's unfamiliar with Finland, so it would be wise to add some major cities or something to help the reader orient themselves. But what I did for this example maps quite quickly was just to add this world map, and then filter it down to Finland and the neighboring countries. First, we'll use the name to say that, okay, just keep these neighboring countries. And then we can get a duplicate. We say that just keep Finland. And then we could indicate the visual hierarchy between these two. So Finland is the primary thing that we want to have visible. Therefore, we can have the other countries that are just there to give the reader some sort of grounding of why this is happening. Then I'll choose the darker color for Finland and lighter gray one gray because it's kind of fading in the background, and then it highlights this quite aggressive red that we have for the wildfires. Good. So we could add something else. For example, a copyright label to have the data credits in there. I think we can move on to show you how to export this animation. So it doesn't export an animation straight away. Instead, what you will get are individual frames of animation. You can press this small icon here, and it gives you a template of where to sort of all these options of what you want to export. Then is the current map view. I mean, it could be something else, but I found it easiest to just work as this, work with this map view. And make sure you draw active decorations live, the temporal range as you want it, and the number of steps and everything. So if you want, you can keep this default step of 1 week. If you want to have it even smoother animation, so you can reduce this step length or step size rather to something like 1 day. But of course, then you will have a lot more frames to export. So then you might want to reduce this time range to make it feasible. Okay, but still the first set the output directory. So you should have a like full empty directory that you have prepared for this export. For example, I have it here. Anyways, yeah. So these hashtags will be exchanged for a running number from 0 to 1, and then it shows which frame you are currently on. And if you change the file ending here from PNG to JPEG, I think that's wise, just to sort of keep the file sizes a lot smaller. Yeah. Once you have everything set up, you can just save, and then it start exporting the animation. Once the export is done, so then you will have a folder. Navigate to the folder that you just chose. So then you will have a folder full of pictures. Look almost identical, but then they are less advanced by the step that you selected. So, and once you render them, you will have something like this roughly. That's shown in the instructions. Except I changed from this May, November, August to numerical dates. Well, the final question then is how to get that video out. I listed a few options. You will have to rely on some external tool. So I listed a few options here from complex ones like this command line tool called MPEG, or Shotcut, which is like a full free and open source software video editor. And there's a few instructions here if you want to go these routes. Probably the easiest one, and maybe the one that you may want to go with, is this QGIS, which is a web page where you can just copy and paste all of the images that you just exported, track them to QGIS. And there's a lot of that small fine tuning that you can do that affects the outlook of your animation, which is, for example, the frame rate. So how fast that animation or video advances through your frames. So play around with these things. There's a stretch code here. So what we have visualized are just these single point events. But doesn't really tell you anything about the severity of the fire. So it treats every fire as equally severe, which of course is not true. And it treats every fire as one that lasts equally as low. If you want to sort of keep delving into this data, I have a sort of suggestion. What you could do here is to use this space-time DP scan clustering. So a clustering tool that I can quickly show you. So you can use to, instead of having raw points, so you could use this clusters or points that are within, let's say, 5 kilometers of each other, and also have this temporal aspect here, so they should occur within, let's say, 1 day of each other. This you could run and cluster these points together, and then there are a few things additional things that you need to do. But if you do this, you could explore like these 5 events, or at least an approximation of them, instead of these single points. Yeah, so in this tutorial, we looked at spatiotemporal exploration of data within QGIS. We looked at animations and how to make them. And we made our own animation of this wildfires in Finland, which personally, I thought it came out quite nicely. Other thing is how informative then this is, but at least these animations can be quite sort of eye-catching. So I think that's their biggest strength. And then if you want to actually show the distribution, whether that be spatial or temporal, so then you can use something like here earlier, these X-bin maps, for example. And the second part of this tutorial will be about web mapping. So you want to give the reader control over your data. So of course, web mapping has been around for a long while. And what's nice is that you can actually export a project that you'll be working on and stylize within QGIS to a web map. So we'll do that. I'll show you a quick example here. What you will need is this QGIS to web plugin. And it tries to have quick map services at your disposal. So we'll need to add a background map, a base map. So what you will have for data is this population by Finnish provinces or maakunta. And you check the attribute table, you'll find that there's a lot of meta information, these names and everything, but then the actual data is population, so counts and shares, male and female population, and different age groups. So the principle of this sort of QGIS to web, like a rule of thumb, basically. So what you want to do is to make everything as ready as possible in terms of symbology, colors, labeling, all of that stuff, all of the visualization. You want to have it as ready as possible within QGIS, and only then export your map. So let's visualize one variable here, which is ICA 65%. Basically, it's the percentage or proportion of population over the age of 65. So what you might use this map for is, for example, to show in like what areas, what places in Finland have a higher share of senior citizens. Visualize it maybe yellow to green. Yeah, maybe something like that. Always think of what you want to show. Is this something that you want to show sort of as in negative light or neutral, or is this, yeah, so that should guide your color choices. Then you should enable labeling and have a name in there. And then I think I always like this buffers around the labels. So have those active. Oh yeah, and then finally add a background map, whichever you want. I will just use the standard OpenStreetMap stylizing. Then let's say that we are now happy and done with this map. Next, we want to export it. So from QGIS to web, like under web. You can create a web map, and this will be rather complicated. So there are a lot of options here. You should check out these different tabs. So one of them is for stylizing, one of them is for the sort of data, what do you want to have visible. There's an export tab, settings, and then a wiki tab. So this wiki is where you want to look at if you are confused about something. So it's quite extensive, but if you have a problem with something, you can probably find your answer in here. And press update preview. And when I did it a bit earlier, so I noticed that there was some sort of update that I had to do within this plugin to enable update preview. So I think you probably need a relatively new version of QGIS and everything for this preview to work. But anyways, this update, this preview will show you approximately how this map will look like once it's exported to this, like other rendering software or system. So you have two options here, Open Layers and Leaflet. Both of them are open source web mapping tools. It doesn't really matter which one you choose. I think I'll keep the default Open Layers one. Like, it's a pretty good approximation of what we have here behind us. Maybe some things change, like this. Like these labels look a bit odd. If we have leaflet enabled. Okay, before export, let's choose a few things here. So we'll want to have a pop-up field. So of course, one of the strengths of these web maps is that you can give the user an option to find out more, to explore the data a bit more. And we can use these pop-ups. So basically, once you click a feature, so then it shows more information about it. But if you have these default settings, so then this isn't actually very useful. We don't want to have everything visible. So we have to select just 5 of these columns to have in there. And it would be quite laborious to click through all of the options here. So instead, you can scroll down here. Oh yeah, here for set all. So we'll set all layers to hidden field. Apply. So now by default, all of these are off. Then we can enable the ones that we want to keep. So name, set that to inline label always visible. Name, then just the count of population, the share of population this specific province has, and then the share of population that's over the age of 65. Then moving on to the appearance. So there's a lot of options here. I won't go through all of them. You can check the wiki for more information. But all of these things that you might encounter in a web map, like a geolocation tool, if the user gives their permission, so they can see where they are. We got titles, filter by attribute, all of this stuff. So layers list expanded. And we can select ICA 65, so edge of over 65. Add a layer search. Aim. Plots and hover. And importantly, we should match the project CLS, so make sure you have this one for Finland. And then as the last thing, we can limit, so make sure that the user doesn't just go wandering somewhere, so we can add this maximum and minimum zoom levels roughly for Finland. Now if we update preview, this will be approximately what it shows. So instead of having a pop-up that's everything, so we just have these few fields, and we have explanations for those. We have a legend here. It explains what's shown, and yeah, I mean, all that looks good enough. So we can keep fine tuning it, but we just export it for now. And you do it from the export tab and make sure again that you have a good location for it. I'm not just now just going to export it to a temporary file, but you should have it somewhere where you can find it if you want to publish it. So I select that folder and then export. And it automatically opens it up in a browser. So yeah, here's like these HTML files are best opened in a web browser. So this shows what your map would look like. And now you have everything. For example, we set up this search feature. So we set that on this field name. So we could, for example, search Uusimaa and then you'll find it. And still a few things. So if you want to publish it, there's a notebook instructions for doing that. Publish interactive maps. There's a link to an example map that are hosted on GitHub pages. So if you're on GitHub repository, you can quite easily host these HTML files there. And this is like, this link leads to an online map that's hosted in there. So by me in GitHub. So it's the same map that I just showed. And then if you have to do this, make sure that you have everything that's exported. So the whole folder, every single thing, web fonts, resources, layers. So you need all of it for your web app to be rendered correctly. Okay, with that, I thank you for your attendance to these tutorials. That's it for this year. If you have any questions, don't hesitate to ask on Discord or other communication means. And good luck with your exercises and then the final assignment.